Thanks for joining us on Building Australia. This is our first episode for 2025. Today's episode, we're going to look at the importance of engineering and how that's going to impact energy efficiency of the home that you may be about to build, and of course the environment too. In today's video, we're going to cover topics such as the use of structural steel in a modern home, how to minimize thermal bridging. Also going to look at how and when to use concrete, when it could be minimised, and perhaps some alternatives to concrete footings that are available today. And also the benefits of modern timber framing and some of the modern hardware packages available today as well. Joining me today is Yashar from Oronic Consulting. Yashar is a civil and structural engineer. Thanks for joining us, Yashar.
Thank you, Andy.
Let's get started. So, Yashar, one of the big things that people talk about with structure in a passive house is thermal bridges, whether it's timber framing or steel framing. In terms of steel, what's sort of the limitations, or how can it be minimized so we're not dragging all that external heat into the building, for example?
I believe that's general to every building, not just passive houses. So new modern architect try to create large open spaces. Because of the urban area, we need the space to be, it's a limited space, and the double story, you need upper level, usually bedrooms sitting on a lower living room, for example.
Yeah.
So you end up with larger span beams, which is usually more than allowed for timber. So that's where most engineers use steel, and sometimes you cannot just get the timber works.
Yeah.
And then quite a lot of houses these days, they have very high walls, like more than 3-4 meters even, especially in the entry, in the void areas, or some of them in a very large void, you can see 5-6 meter high wall. So these are the area usually engineers have to use steel to be able to get the structure works and
to make those big openings. And sometimes you've seen these really modern buildings, these huge cantilevers over the entrance. Yeah. So can you explain to us how a thermal bridge occurs for someone who's never considered this before when they're designing a house? How does this occur? What's actually happening behind the scenes?
That's correct. So steel has a very high thermal conductivity compared to timber.
Yep.
And it's when you need it, for example, a cantilever, as you mentioned, you are going from the warm side of the building to the cold side outside, or the other way in summer from the very comfortable environment inside to a very hot temperature outside. So that brings heat and cool inside to the building. Which in passive house in general, as you mentioned, we don't want that, because we want to keep the temperature consistent. We just want to make sure our thermal load is limited to the number that it's in our spreadsheet for the passive house.
And also consistent, so we don't have hot and cold pockets in the building forming condensation and discomfort. We want a uniform sort of temperature across the whole building. So
that's correct. And the majority of the people are pushing for passive house or high performing homes. They also very like-minded about the sustainability. So steel comes with a really high amount of carbon as well. So if you can reduce the amount of steel, you get two benefits: reducing the thermal bridging, reducing the carbon footprint, embodied carbon in your structure. So I think we're going to talk a little bit about how can we do that and how can we minimize that one and reduce the thermal bridging as well.
Yeah, and obviously the benefits at some point when the life of the house, comes to an end, and people are going to, destruct that, or deconstruct that, I should say, in 50 years or 100 years, the timber is very easy to pluck out and recycle.
That's correct.
So there's that sort of long-term benefit as well.
Absolutely, yes, it is. It's compostable as well, so you can recycle, you can reuse it. It's a lot. You can reuse steel, but really, usually, every structure you need exact number of steel member sizes or the length. So it's not that easy.
Yeah, it's not going to be plucked out and used on another job somewhere. It's just going to be transported. And I think this is the other thing that I've always had a problem with heavy building materials, whether it's steel, brick or concrete. There's a lot of embodied energy just in the transport. The amount of trucking that's involved to bring this stuff from place to place into its final, building site. It's huge amounts of embodied energy just in the transport, let alone the manufacturing of these products. So we need them, we can't avoid them, but I think using them with a bit of mindfulness is the way to go. So we're going to look at also concrete. one of my enemies to sustainable building and just impact on the environment. It's right up there in terms of its carbon contribution. There's now some great alternatives, Yashar. What have you seen in terms of alternatives for concrete footings?
That's a great question. For the concrete footing, of course we like to go towards the subfloor system.
Yep.
So it comes with a much less material in terms of the cubic meter. So concrete is a great product, but it comes in volume, as you said. It's a lot of volume involved. So more volume, you get more embodied carbon into the material. So and it's fairly high carbon intensive material, concrete. So with the subfloor system, a very traditional system is a stump. But when we look at the durability of the structure, especially with a high-performing structure, we like to extend the life of the building. We're building a great product for the people to live maybe for generations. So maybe like as an engineer, we also try to push for the performance as well.
Yeah.
And the stumps are good, but you cannot usually get the same performance as you get with the concrete slab structure.
Yeah.
So there are great alternatives like screw piles, shore foot, all foot, mega anchors, different type of foundation which they're easier to install, much less material. When you compare it with a concrete slab, lower energy, lower carbon, embodied carbon, and it performs really well. So it has to be carefully designed, but they are available in the market, easy to install, faster to install,
very fast.
You get a much better insulation and air tightness when you come with a subfloor system as well. So it's cheaper to insulate it as well. So that's
Correct.
a good option.
I guess it's probably worth to look at some of the pros and the cons here as well, because some people have a preference for concrete. And I've had this, Rob, explain someone all the benefits of using a lightweight subfloor system. For example, the benefits of airflow underneath, permanent sort of adjustability if there's enough room under there, which there almost always is to adjust the height of things. The concrete, the feedback I get from people who are adamant about having concrete is its permanence. So that is valid and one of the pros. And there's some famous, buildings in concrete around the world that are now thousands of years old. So it does have that. I won't deny that. But when there's so many alternatives now to a concrete slab, you have to talk about it, I feel.
That's correct. Look, I think two things are very important, which usually neglected in the building design at least for the time I've been in the industry for the last 20-25 years, is the site drainage and also the proper ventilation. So for example, in Victoria, Melbourne, we have a lot of slopey sites. So because there's always a height limit with the building envelope and the site setbacks. So the architects or designers, they try to do propose a site cut. So when you go down, you're cutting already 1 meter, for example, at the back of your lot. You're very close to the ground. You don't have enough clearance to the ground. You don't have enough you don't have adequate drainage if you build from the boundary to boundary, so the moisture is critical. So of course the concrete slab is a better option for those sort of projects. We have done subfloor with a proper drainage design. Usually when we are engaged for a job, we do both civil and structure.
Which is a better combination too. I've seen this where we've had two different engineers involved in the project and not necessarily talking to each other. So if the same engineer is doing our drainage plan and everything else, it flows. It makes much more sense.
It does. Look, I think the industry is improving. Quite a lot of authorities like building survey councils now, they're very cautious about the drainage performance. They check the ventilation thoroughly. They want to make sure it's comply with the NCC requirements. So that pushes us as designer engineers to learn more. It's a continuous learning. So some of the items are picked up these days by the authorities. I never heard about them like 10 years ago, which is good. It makes our job more difficult, but it's in a good way. I mean, we have to learn more and we have to implement. We have to show more in our design documents. So all of this comes with a cost for the clients as well. So I believe the fees for designers is increasing. One of the reasons is because the compliance items are more comprehensive and they need to address more as well in their design documents.
And you're right. I think stakeholders like council, building surveyors, insurance companies, they're having more input now. And that's making these civil plans a bit more comprehensive than where they were only 10 years ago. I mean, now what I see is quite extensive. Sometimes it seems a little bit too much, but for the life of the building, it will pay off.
Yeah, I think we're all well used to it. You know, if at the moment
Yeah,
it feels too much,
yeah,
but not every builder really operates like you do, that
mm,
much careful about everything. So
yep,
I think many people also needs to, they rely on designers and authority to do the good job,
yeah,
which is I believe overall for the industry is a good thing, is not a
yeah.
bad thing.
Going back a little bit to moisture, because this is something I've had an experience with recently. I did on my own house, and I might make a video about this just to sort of show people. We've been there for about 7 or 8 years now, and I put in some drainage on the road, thinking, yeah, of course I want drainage because it's very flat, and I imagined it flooding, so I'll put in some 6-inch drainage. And but what I've actually done is I've dried out the soil around the house, and our place is it's 60 years old now. It is a double brick concrete structure, and the soil everywhere now has shrunk a little bit, and now the house is sort of cracking away a little bit. So, in terms of a new build, what can be done to, first of all, I guess, analyze that? And so, what is our moisture content? How do we go on monitoring that after the build and keep that sort of consistent so we don't have that soil shrinkage and footings shifting?
Oh, it's a very good question because it's different story between the new build and an existing build
Yeah.
improvement. So for the new build, you want to maintain the moisture under your foundation pretty consistent.
Mm.
There are some requirements in the National Construction Code, but apart from that, a good drainage from the beginning of the build is really important. So the
Yeah.
builder has to implement them right from the start of the foundation construction. I've seen on many sites, for example, they leave the downpipe open,
Yeah.
no temporary, the water keeps going under the
And
footing,
the
and then
soil's just swelling.
correct, yes. So at even when the building finishes after like a year or 6 months,
Mm.
and then after 1 year after that one, it starts changing the moisture.
Mm.
Especially if you get a heavy rain, it's a lot of amount of water. If your site doesn't have a natural drainage performance, like you said, for example, a flat site, it
Yeah.
takes time to be dry. It's under the ground. The temperature
Mm.
is not like outside. So that changes the moisture, and you see cracks happening very quick
Mm.
without any major trees, even without any
Yeah.
planting near your foundation. So it's, it has to be well taken care, really. I mean,
Yeah.
for an existing one, as you said, if you had an area which you sort of inviting the moisture on close to your footing, that's the natural moisture of the soil in your area, and it
Yeah.
was performing well.
Yeah.
It means it's okay.
Yeah.
When you change that one, so it changes the situation. Yeah,
Learnt
it's
that one the hard way. So is one of the solutions to this less but deeper footings? Because my understanding is, and you'll know this off the top of your head, but once we get down below about 1.5, that moisture content's not changing much, is it?
No, that's correct. But also it's about the plasticity of the clay.
Yep.
We have a highly reactive clay across Australia. It depends in if you're in a western suburb in Melbourne or eastern suburb. The soil, like you know, you usually hit the shallow bedrock at the eastern suburb, but not happening in the greenfield or western suburb.
Mm.
So it's a bit different. That's why, for example, for a like a class H2 highly reactive site, you need to go deeper compared to a class M moderately reactive or
Yeah.
a class S. So again, selection of the footing is important. Well, we mentioned about shore foot, for example. The rod's usually 1.5 meter. You cannot go very deep with them.
Mm.
If you are a very reactive soil, like extreme reactive soil, maybe the designer needs to be careful. A use of a board pier or a screw piles, which can go 3 meter deep, for example, is a better option.
Yeah.
So, I mean, these are the things, it's not enough knowledge in the industry. I myself, I keep learning, which is a good thing. We feel there is always
Yeah.
new things to learn, but
Yeah, there is too.
it's a new product, for example, come to the market. It still hasn't shown the performance for the 10 years or 20 years,
Yeah.
but definitely much better than a conventional stump, for example, which you
Yeah.
only go 900, 600, 700 mil. So you go deeper, you improve the performance. Is it enough? You need to wait and see, for example, 20 years, 25 years, see how it
Yeah.
performs. Yeah, definitely for a lower reactivity site is perfect, but if
Yeah.
you high reactivity, that's maybe one of the reasons some people are more towards the concrete,
Yeah.
but it doesn't mean concrete performs excellent as well.
It's ultimately it's all sitting on soil at
That's
some
correct.
point.
Yes, correct.
Whatever footing system it is, it's really going to be dependent on the soil that's sitting on, not the engineer, not the builder, not the quality of the concrete. It's the soil that's sitting on, and then our founding depth is going to help us there.
That's correct, yes.
And I think one of the things, just going back a little bit to the lightweight footing systems like Mega Anchor or Surefoot, one of the things that really appeals to me as a builder is it's got this huge 20 mil nut on there. So if anything moves in the future, and generally these are fairly lightweight houses that we're building, we can jack that house up 20, 30 mil quite easily. I don't think we'd ever need to go that much, but any of those minor adjustments, we can lift it up and tighten it up and re-secure it. So for me, having that ongoing flexibility is, well, nothing else I don't think can really do that.
Yeah, so this is really something I believe was to be added to our Australian standards for the residential slab and footing. Steel stumps in general,
Yeah.
not necessarily on the shore foot or screw piles, can be just on the board piers,
Yeah.
but give you that flexibility. You just can adjust it. It's
Yeah.
really great, and it's if you have a steel base plate sitting on any type of footing that you can adjust it.
Yeah.
And then, like for example, in your house, you change the moisture, it moved. I don't think it's gonna move again and again because
No.
you manage the drainage there now. You probably get some sort of a balanced moisture in after a while, and then you can make sure if you can lift your house. Of course, it's very difficult for a full brick house, concrete house. You cannot do that, but with a lightweight system, you have the flexibility. And what I love about lightweight system is you you use much less material and much less structure, more sustainable structure,
and it's going to be cheaper.
yeah, it's a bit of a we need to think about sometimes, is it a 3 meter high ceiling is required? Maybe if you can reduce that one to
Compromise
2.7, you can get that clearance, you can design that one. We have job even in a side cut with some perimeter block work. We can manage the flood, we can manage the drainage, and then still you have a lightweight system. It's a great subfloor, enough ventilation. It's protected from the outdoor environment as well. So even in the bushfire area, even BAL like 29, we do subfloor with some lining under the floor system.
Yeah, it's not too many conditions on a BAL 29 build either. It's fairly comfortable. It's not too much of a stretch.
That's correct, yes.
Yeah, okay. So one of the other really important topics is timber framing. We do a lot of it. I think we always will. There's just so many benefits to timber framing. It's low impact. It has full flexibility on site. It's cost effective, minimal thermal bridging, which is one of the topics that I want to go over with you, Yasha, in terms of how can we be using timber framing to our advantage to make a home more efficient.
Yeah, I think we touched on a little bit about the steel and thermal bridging in the beginning. Now we can go a bit more deeper into that one. You asked the question, for example, how can we avoid a steel cantilever or long span steel? So engineered timber product like LVL, glulam, and even some other items like, for example, CLT and so on. They have great capacity with a bit of a structural allowance. For example, if we can use, it's readily available 400 LVL, you can replace a lot of steel members into that one. You can get more cantilever. With some creative design idea, a bit of a thinking of, for example, using a LVL portal frame, which now Simpson Strong Tie has a kit.
Yeah, and they are great
yes,
kits.
Mayer Timber also introduced another one recently, which is good. We have two options to choose. Very high capacity timber portal. You can use them and, for example, avoid a steel portal frame. Or for a passive house in a specific, we mostly use 140 external wall frame. It means we can go much higher. We can get a better capacity. We can have larger timber beam lintel concealed into the wall instead of for example, in 90 frame, you can only use double 45.
Yeah, you end up losing so much of the frame.
Yeah, but you can do triple times of that one in a 140 studs. Yes.
Can we, with the 140, can we extend these out to 600 center framing and get rid of the noggins?
It's possible, especially if you have a cavity battens inside.
Which we would on both
sides. Or maybe
I think.
OSB brace outside. You're restraining your studs. You can get rid of noggins, less material, less thermal bridging. Timber is great in thermal conductivity, but it still has thermal bridging. So by increasing the spacing, you can reduce the thermal bridging of timber as well. A job came to us in 2019 in Blue Mountain, which was full. It's like a mezzanine type house. At the back, it was double height. At the front, had the mezzanine level. It was all like a like a shed style portal frame, and an engineer designed that one. With the 140 stud, with some wind beam and some creative bracing, we changed the whole house to timber. We had a steel subfloor, but above that we had full timber. It was a prefabricated house as well, which we built in Victoria and then transported there.
Yeah, okay.
But I
Was
mean,
this like a prefab sort of insulated system?
that's correct,
Yeah,
yes.
possibly from
Carbon light,
carbon light,
yes,
of
carbon light.
course. Yeah,
And it was all like a raked ceiling, gable
yeah,
roof. I mean,
yeah,
you don't believe it.
yeah,
We spent a bit of a time, worked together with carbon light to make that a timber, but it did work, and the builder was very happy, installed
yeah,
it on site, and it's there. It's a
yeah,
high wind area. I mean, it's work. I mean, when the job came to me, I told them I'm not sure if I can remove all the steel,
yeah,
but we can remove a lot of it. But we managed to remove all the steel above
yeah,
the
yeah.
subfloor.
I mean, that is a phenomenal system. Also, the carbon light system, like the on-site time is reduced. The thermal performance of the structure is second to none. Yeah,
Yeah,
they do make a great product. So the other advantage I see of going to 600 center framing with the 140 studs is by reducing the studs, we reduce the thermal bridges. By removing the noggin, we can also then have continuous insulation.
correct, yes.
Because one of the things that I see on site is every time there's a break in that flow of insulation, whether it's a noggin or a service, it frustrates the insulation guys. And I always tell everyone, give the insulation guys 450 centers everywhere, because they'll install their bats perfectly if we make it easy for them.
Yes.
And my thinking with this is 600 centers means you can have, from floor to ceiling, you can have continuous layer of insulation, unbroken.
Yeah,
So I see a lot of advantages there.
that's great.
Yeah.
Yes.
So the portal frames, Yasha, is something that not everyone's going to be familiar with. A portal frame is bracing. How is that working?
The new, again, modern house design, it's a lot of large windows.
Yeah.
Like in a passive house, we want quite a lot of north-facing windows,
Yeah.
and then there is no wall to brace.
Yeah. So it's the absence
yeah,
of a wall in place of a window where
That's
we
correct.
want extra bracing. That's where the portal comes in.
That's correct. And the first thing every engineer goes to is create a steel portal frame,
Yep. Yep.
which sometimes we have to, but I mean, many times I ask architect, instead of a like allowance of 150, which you've given me between the windows, can you give me 240 mil so I can use a double 240 LVL column, or give me 300 mil to use a double 300 LVL column?
Yeah.
The windows become a smaller 100 mil, 150 mil, but then I have a timber there instead of a steel frame.
And the strength in that timber join now is similar to steel. The way we sort of cross laminate these members, glue and screw them, that effect this way is similar to steel now.
Yeah, it may not be similar, but it gives you the number you need in terms of the comps. It still need to be comps. So I mean, we still need to do calculations, see if it works or no, if it's enough or no. It depends on where your house is located. It's like near the bay or in the middle of the jungle, for example. It different wind pressure. It has to be designed. But the thing is, it's the timber overall with a timber frame. The timber material blend much better with the structure. It's all fixed, you know what I mean? With the, still you need to do the patchwork to make sure your steel frame works together with your timber frame. But
which is tricky at times, because no one likes fixing to steel. You have to pre-drill and screw, it's slow and it doesn't always work that well. So if we're sticking with timber everywhere, everyone's familiar with that. Every other trade that's going to come after the frame carpenters is familiar with timber. Everyone has a fixing method into timber, but into steel, everyone goes running. It's just hard work.
We did a job again, maybe it was 2020. We had all this like a cranked roof style, gable style. So we couldn't get the timber to work because the span was long, and architect and the owner, they didn't want the large timber column exposed into the living area. So we used the steel column into the 140 stud wall, but we used the crank timber beam. I mean, you can even have mixed them and reduce the steel, add more to the timber, and just design the connection to works for that scenario, and it works well. And again, in like a 140 stud, even if you fit a 90 mil or 100 screw hollow section, you still can insulate that one. Put some XPS at the front. You have your continuous insulation. It will be still a bit of a thermal bridging, but much less compared to like a larger steel, for example.
And that's the other thing that does need to be done with steel when you have to use it. there's a lot of insulation products now that you can fill that void in the steel section with XPS or EPS insulation and wrap it up quite effectively. So it still can be treated, but sort of needs to be planned ahead. I always say if it's not drawn, it probably won't get done.
Yeah.
So it needs to be planned ahead for.
That's
So
correct.
yeah,
Look, it's if an engineer is familiar with the thermal envelope, uh, maybe we need a bit of education in that space. I've been lucky working in with the passive house builder and
you've
architect
made
for
it your
the last,
specialty.
so it's a bit different, but I believe it's well worth it now when
Yeah,
we're talking
yeah,
about increasing the energy rating of the houses.
yeah,
So that
yeah,
that all comes into effect. So then, if engineers aware of that, then they can try, or the designer can ask them, or the builder can ask them to separate the structure from the internal thermal envelope and the external. For example, you don't need to connect your pergola, a steel pergola, to your a steel frame inside the house.
yeah.
You can have a connection
Detached.
designed just,
Yeah,
yes, just to make sure. Like for example, in some of the jobs we have done, we fit a small steel columns behind the cladding outside of the
outside of
building.
the
We just screw them to the, like a double stud behind them, so
yeah,
it's make sure it's all braced,
yeah.
but it can be totally outside.
And then you have a batten system that takes the cladding over that
That's
steel.
that's correct.
Yeah,
Yeah. So it's
yeah,
concealed. No one see that one,
yeah,
and then it's same
yeah,
design will be achieved
yeah.
without compromising the thermal performance and the
And
thermal.
it's something we do a lot of anyway. Typically with a high performance home, the wall build up is going to be quite thick.
Yes.
So a conventional clad frame home, which means no brickwork, generally is only going to be 120, 130 mil thick. Whereas if we're starting with just a timber frame, no brickwork, we're going to start at 90, possibly 140. And we're going to keep adding some layers for airflow and insulation and eliminating thermal bridges. So even at the smallest, our walls may end up being 150 to 200 mil thick. So then, like you said, to conceal that bit of steel in there is quite easily
It is
achievable.
possible, yes.
Yeah,
Yeah, it is
yeah,
possible, but I believe the word need to be spread, so more people come on board and try to use that one. Some of the carpenters, trades, they are used to do something which they have been doing for the past like 30 years.
yeah, yeah,
It's a bit difficult to shift,
yeah,
but if I push them into my drawings, if the designer tell them, look, we need that because we want this performance,
yeah,
so they have to follow. And when they do it once, they can do it again. That
yeah.
shouldn't be a problem.
I think the market's going to drive this anyway. When people start to see a new build down the road and they see their power bills and they see their own power bills, the market will drive this. I mean, we haven't seen it yet in Australia, but it will come up eventually where when you buy a house, whether it's a new house or an existing house, it'll come with an energy rating, independently verified energy rating to say this is how many kilowatts and how many megajoules it might use in a year. And that will play into people's decision making when they're buying a house, as well as aspect. So that's not here yet, but it will be in the
It
future,
will
I'm
be.
sure.
I can see that it's happening in the market. Yeah, it
Yeah.
usually starts from some specific pocket of the town, but it spreads fast.
Yeah,
Yeah.
yeah. People see the benefits, and especially when, we're talking about energy a lot. So there's a new house down the road here that's been built. It's only 6 months old, and they are suffering in summer. They're suffering. They've got split systems running all the time, and they can't, on a hot day, they can't get their house down to a comfortable, even 24, 25 degrees inside.
Yeah, that's not good.
So
So it's for a new house, you
for a
don't
new
expect
house,
that.
yeah.
Yes, yeah.
So these are the sorts of conversations I think will drive positive change, but it's going to take a bit of time. Yeah,
Yes, I think this is a bit tough on us professionals to educate the end user.
yeah,
That
yeah,
come to us. We talk about, at least we let them know there are existing. Many people when they just want a home, they want a big kitchen or a living room
yeah,
or beautiful windows, but they never thought about, okay, these windows can have a better performance, or
yeah,
the structure can be thermal bridge free or minimum thermal bridging. So I mean,
yeah.
if we can give them the message, I'm sure they come on board. Who doesn't want a comfort? So everyone likes
Yeah.
that.
And if these things are built into the home, you only pay for that once. So I do sort of suggest to people, if it means compromising on something else, like a paved driveway or something, invest in the extra 10,000 or 15,000 in the better windows, because that's permanent, and that saving is there forever. So there you go. Thanks, Yashar, for joining us today. And if you're thinking about building a new home, have that conversation with your architect. Are your consultants on board? Are we going to go down this path with some accuracy and some knowledge to make your home as efficient and as comfortable as it can be. Thanks for joining us.